Welcome to Math 104. We're working on section 7.4 today, adding and subtracting radical expressions. Please start with a warm-up. We're going to simplify these two expressions. So we'll take the square root of each part individually. Square root of 4 is 2. Square root of x squared, divide the exponent by 2 to get x to the first power. And y to the 8th, we'll divide that by 2 to get y to the 4th. 2xy to the 4th power. Now here we're going to have to factor this into things that are perfect quads and then the leftovers. So 16 is a perfect quad, so we will do the 4th root of 16 will be over here, and 32 breaks up into 16 times 2, so 2 ends up in the leftover part. Now x to the 9th, we need the largest multiple of 4 that's less than or equal to 9, so that is 8. So we'll put x to the 8th power over here, and the leftover x goes off to the right. And here we have y to the 23rd power. Largest multiple of 4 that's less than or equal to 23 is 20, so we'll put y to the 20th here. And the 3 leftover y's go over here as y to the 3rd power. So that gives us fourth root of 16 is 2. Fourth root of x to the 8th is x squared. All right. 8 divided by 4. 20 divided by 4 is 5, so that gives us y to the 5th power. And then we'll write down our leftovers. Fourth root of 2, x, y to the 3rd. Now take a look at the next part, adding and subtracting radical expressions. And we have a list there of terms. Which of the following terms can be added or subtracted? The first list here, where like terms are those where the variable part is exactly the same. The only parts that match are with 7xy and 8xy. You got the matching variable part xy. Well, the same idea holds for radicals. We can add and subtract those together, but they have to be like terms. They have to be exactly the same. So we have to look at both the radicand, which is the expression underneath the radical, and we also have to look at the index. Those must be the same, or the index. The coefficients do not have to be the same. So if we look at these expressions, we've got a square root of 2x squared here, and this is the third root, so those don't match. Here we have a third root of 2x squared and a square root of 2x squared. Those are not like terms because they have different indices. The only two that match are the first one, 7 times the third root of 2x squared, and the last one, 5 times the third root of 2x squared. All right, now we're going to add these together. Now keep in mind when we add or subtract things, the thing that we are adding or subtracting never changes. If I take 3 basketballs plus 5 basketballs, I don't get 8 umbrellas, right? I get 8 basketballs. The thing doesn't change. So the thing that we are adding is these fourth root of 5x to the 3rd. Should be a 4. Alright, so we've got these things called fourth roots of 5x to the 3rd. And those are the things we're adding together. We have 9 of them, 6 of them, so that gives us 15 of these things. So 15 times the fourth root of 5x to the 3rd power. Your turn, number 1. Right, the things that we are subtracting are 6th roots of 3x to the 4th. And we have 12 minus 4, which is 8. So we have 8 of those. So that's fine if the radicals are identical. But what if they're not? Well, we need to make them identical. So we're going to use the skills that we learned last time in simplifying radical expressions to make them equal and then combine them. So here we have square root of 48 and the square root of 3. So we want to express one of these so that it's equal to the other. Well, generally we're going to be breaking up the bigger number. And the smaller number is a clue as to how that can happen. So a lot of these problems, they have a clue built right into them. So we want to create an expression over here that has the square root of 3 in it. Well, how do we break up 48? We're going to break it up into the square root of 16 times the square root of 3. Now we can evaluate this, because this is a perfect square, so that's 4 square roots of 3 minus the square root of 3. And now we have like terms. We have 4 square roots of 3, and we're going to subtract one of them. So that gives us 3 square roots of 3. Your turn, number 2. All right, so you want to break up this into something times 5. And that would be 25 times 5. Square root of 25 is 5. So that gives us 5 square roots of 5 plus the square root of 5. Now we got 5 of them here, we got 1 of them here. We'll add them together to get 6 of them. So 6 square roots of 5. All right, over here now we have coefficients on each of them, so we have to be a little bit more careful here. 2 square roots of 11 plus, now we're going to break this up, 3 times the square root of 4 times the square root of 11. That gives us 2 square roots of 11 plus 3 times 2, evaluate square root of 4, square root of 11, and final answer is 2 square roots of 11 plus 6 square roots of 11, which gives us 8 square roots of 11. Your turn, number 3. (63) breaks up into 9 times 7. So we got 10 square roots of 7 minus 2 times 3 square roots of 7. So that's 10 square roots of 7 minus 6 square roots of 7, which equals 4 square roots of 7. Now we're going to look at some with some variables. So we've got a variable in there, but the variable part's already matched, so we don't really need to worry about them. We want something times 5 over here. That'll be 9 times 5. So we'll break this up into the square root of 9 times the square root of 5x, keeping the 5x matching here, plus 6 square roots of 5x. All right, this turns into 3, so we get 3 square roots of 5x plus 6 square roots of 5x. Add them together, and we get 9 times the square root of 5x. Your turn, number 4. And we want to break this up into something times 7. And that is 16. 16 times 7 is 112. So it'll be square root of 16 times the square root of 7x. Want those to match. Square root of 16 is 4, so we get 4 square roots of 7x minus 2 square roots of 7x. Subtract those and we get 2 square roots of 7x. Now we're going to look at one with cubes. 8 times the third root of 3x squared minus 2 times the third root of 81x squared. Alright, so we have 3x squared over here. So we want to break this up into something times 3, and that'll be 27. 27 times 3 is 81. So this becomes 8 times the third root of 3x squared minus 2 times the third root of 27 times the third root of 3x squared. Now we've got a match, so that's good. All right, now I'll evaluate this. So we get 8 times the third root of 3x squared minus 2 times third root of 27 is 3 times the third root of 3x squared. That turns into 6, so we get 8 times the third root of 3x squared minus 6 times the third root of 3x squared. Subtract those and we get 2. So 2 times the third root of 3x squared. Your turn number 5. And we got a 2x over here, so we want a 2x over here. 2 times 125 is 250. So that's how we'll break up that one. 3 times the third root of 2x plus 2 times the third root of 125 times the third root of 2x. Now we've got our matching third roots of 2x. So this turns into 3 times the third root of 2x plus 2 times third root of 25 is 5 times the third root of 2x. Now we'll multiply these out. And add them together, and we get 13 times the third root of 2x. Now in the next example, we're going to need to make sure the variable expressions match. Alright, square root of x to the fifth plus the square root of x. We want to get a square root of x over here. So what we can do is break this up into x to the fourth power times x. So we'll take the square root of x to the fourth times the square root of x plus the square root of x. Now this becomes x squared. So we get x squared times the square root of x plus the square root of x. Now to make it all one term, we want to factor out the square root of x. And we put x squared plus 1 in the parentheses. Your turn number 6. All right, we want to match the square root of x over here, so this will turn into the square root of x minus the square root of x squared times the square root of x. We're broken up x to the third power into x squared times x. Now this becomes x, square root of x squared is just x. So we have the square root of x minus x times the square root of x. And now we can factor out the square root of x and get 1 minus x in parentheses. Now we're going to combine these two together. In the next examples, we need to match both numbers and variable parts. All right, so you don't have the clues in this one, so we have to simplify both of these. All right, so here we can take out an x squared, leaving an x behind. Here we can take out x to the fourth, leaving an x behind. And we can get a square root of 16 here. All right, so there's our perfect squares. And the leftovers for 80x to the fifth are 5x. All right, now we're going to simplify over here, and we should get a square root of 5x. All right, so we can break up 20 into 4 and 5, 4 being the perfect square, and 5 is the leftovers. And the perfect square of x to the third is x squared, leaving 1x remaining over here. And there's our two matching radicals. So there's a check you can do after your first step. You should get a match here. If not, you have to go back and check your simplification. All right, here this simplifies into 4x squared times 5x. And over here, square root of 4 is 2, square root of x squared is x. We get 2x times the square root of 5x. Now we can factor out the square root of 5x. And we get 4x squared. Actually, we can factor out a 2 as well. Factor out a 2x. Factor out all sorts of stuff. Let's just keep it like this. Lots of different ways you can write that one. All right, next example. Should say your turn number 7. So 27x to the 7th plus 12x to the 5th. All right, let's see how we can simplify this one. We need square roots. So a square root factor of 27 is 9. Or a perfect square factor, I should say. So square root of 9. And now we need to pull out the highest even number, less than or equal to 7, that is 6. So 9x to the 6th power. These are all the perfect squares. And the leftovers are 3x. So when we factor over here, we should get 3x. All right, 12 we can break up into 4 and 3. And x to the 5th, highest even number, less than or equal to 5, is 4. So we get x to the 4th here, and the leftover x here. So now we got matching radicals there. So that's great. Now we'll simplify these. This turns into 3x to the 3rd power times the square root of 3x. And over here, this turns into 2. Square root of x to the 4th is x squared. So 2x squared times the square root of 3x. Now we'll factor out the radical. And we get 3x to the 3rd plus 2x inside, or plus 2x squared inside the parentheses. All right, next up we'll look at some higher indices. So in this example, This one's already simplified, so this one does include a hint. We're going to break this up into something times 4x. So we can have an 8 over here, and x to the third. And then we'll be able to simplify that. And then the leftovers are 4x, right? 8 times 4 is 32, x to the third times x is x to the fourth. All right, now we got our matching, third root. Now we can simplify this. So we get 3 times the third root of 4x plus third root of 8 is 2, third root of x to the third is x, times the third root of 4x. Right. Factor out third root of 4x, and we get 3 plus 2x inside the parentheses. Your turn, number 8. All right, now we want to get the matching 7x. So over here, we'll break this up into the square root of 4x to the fourth times the square root of 7x. All right, we've got our match. Simplify this. We get 4 times the square root of 7x minus 2 times, and this will be square root of 4 is 2, square root of x to the fourth is x squared times the square root of 7x. Right, this becomes 4x squared. Now factor out square root of 7x and get 4 minus 4x squared inside the parentheses. And if you want, you can factor out the 4 as well. All right, now we'll be simplifying both expressions. To find a common radical, so do the square root of 80 minus the square root of 45. All right, so now let's simplify both sides and see if we can come up with a match. So here, we break this up into the square root of 16 times the square root of 5. All right, there's our largest perfect square. It's a factor of 80. And over here, we can break this up into the square root of 9 times the square root of 5. Evaluating the perfect squares, you get square root of 16 is 4 times the square root of 5 minus 3 square root of 5. Subtracting, and we get square root of 5. Your turn, number 9. All right, simplifying these. $108 breaks up into 36 times 3. And 12 breaks up into 4 times 3. So square root of 36 is 6. We get 6 square roots of 3 plus 2 square roots of 3. Add them together to get 8 square roots of 3. We're looking for perfect squares here. A perfect square factor of 75 is 25. So break this up into square root of 25. 3 over there. And we need to break up x to the 9th. We have an index of 2. Largest even number, less than or equal to 9 is 8. So x to the 8th over here, and x over there. And then over here, we can break up 12 into 4 and 3. And then x to the 7th, Largest even is x to the 6th, with 1 left over there. Now we've got our matching 3x's. To evaluate this, we get 5x to the 4th power times the square root of 3x, plus, over here we get 2x to the 3rd power times the square root of 3x. Factoring out the 3x, that gives us 5x to the 4th plus 2x to the 3rd. Your turn, number 10. Simplifying this, we have 36, which is a factor of 72. So we'll break this up in the square root of 36 times x squared, with the leftovers being 2x. And over here, we'll break this up in the square root of 4x to the 4th times the square root of 2x. Now we can evaluate. This becomes 6x times the square root of 2x minus, this becomes 2x squared times the square root of 2x. And factor out the square root of 2x, and we get 6x minus 2x squared. All right, let's look at some higher indices now. 6 times the 3rd root of 16x to the 7th plus 4 times the square root of 200 x to the 5th. All right, we'll simplify this first. We want perfect cubes, so 8's a perfect cube that's a factor of 16. So let's do 6 times 3rd root of 8. Highest multiple of 3 that's less than 7 is 6. So x to the 6th power there. And the leftovers over here, 2x plus 4 times. And then over here, we have an index of 2. 100 is a factor of 200. So we do square root of 100, x to the 4th times the square root of 2x. All right, simplifying over here, we get 6 times 3rd root of 8 is 2. 3rd root of x to the 6th is x squared times, whoops, messed up there. That should be 3rd root of 2x. All right, make sure you get that. I forgot that. Plus 4 times square root of 100 is 10. Square root of x to the 4th is x squared times square root of 2x. All right, so now we're going to simplify a little bit. 6 times 2 is 12, so we get 12x squared times the 3rd root of 2x plus 4 times 10 is 40, so we get 40x squared times the square root of 2x. Now at this point, we would normally factor and combine, but we have different indices here. Third root here, square root here, so we cannot combine this, so we're going to leave it just like that. And that brings us to your turn, number 11. All right, we'll start simplifying here. We want 3rd roots. 64 is a 3rd root, or is a perfect cube. It's a factor of 128. So we'll break this up into the 3rd root of 64, and then x to the 4th. Highest multiple of 3 is 3, so 64x to the 3rd in the left-hand side, and the 3rd root of the leftovers, which are 2x. Now over here, you can do 2 times. We're looking for square roots here, so we'll break this up into 36 x squared times the square root of 2x. So simplify over here. Third root of 64 is 4. Third root of x to the third is x. So we get 4x there times the third root of 2x minus 2 times square root of 36 is 6. Square root of x squared is x times the square root of 2x. All right, simplifying. 4x times the third root of 2x minus 2 times 6 is 12. X square root of 2x. So again, we got a third root here, square root here, so we cannot simplify any further, and we're done. Now we're looking at some expressions that contain fractions. And in order to be fully simplified, we cannot have any radicals in the denominator. So if we end up with a radical in the denominator, we're going to get rid of it through a process called rationalization. All right, so we're going to start off by simplifying as much as possible. So over here, we're going to break this up using the quotient property, square root of 48 over the square root of 25, minus, and over here, square root of 2 cannot be simplified at all, but 98 can be broken up into square root of 2 times the square root of 49. And look for ways to get things to match like that. All right, now we have square root of 2 on top, square root of 2 on the bottom. Those are going to cancel. Now, square root of 48, this can be simplified. We're going to break that up into square root of 16 times the square root of 3. All over, square root of 25 is 5. Over here, square root of 2's cancel, leaving us with just square root of 49 is 7, so 2 times 1/7 over there. All right, now that's going to have a 4 here. So that's 4 square roots of 3 over 5. And what we can do now is simplify things a little bit by incorporating this up into the fraction. What we can do is 9 times the numerator, which just gives us 36. So a little easier to work with if we just put 36 there, and then over here, put the 2 on top. So now we got 2 7s. All right, now to combine, we just need a common denominator. So we'll have a common denominator of 35, so multiply this one by 5 over 5, and this one by 7 over 7. Multiplying that out, we get 252 square roots of 3 over 35, minus 2 times 5 is 10 over 35. I think I did that right. Yeah, 252. Okay, and then we can combine. So that gives us 252 square roots of 3 minus 10 over 35. Your turn, number 12. So we're going to break this one up and then simplify over here. So we got 2 times square root of 32 over the square root of 36 plus 2 times, and we'll break this up, so that's going to be square root of 9 times the square root of 3 over, and this 108 is 36 times 3, so we get the square root of 36 times the square root of 3. Alright, now we got a match here, so we can cancel these. Over here we're going to get the square root of 6, and we'll break this one up. So 32 breaks up into 16 times 2, and square root of 36 is 6. Now over here, we got 2 times square root of 9 is 3, square root of 36 is 6. Alright, evaluate this one. Alright, so that gives us 2 times 4 times the square root of 2 over 6. And over here, multiply 2 times the numerator to get 6 over 6. Alright, multiplying this by numerator, we're going to get an 8 here. 8/6 reduces to 4/3. So 4 square roots of 2 over 3 plus 1. Now 1 can be written as 3 over 3. So that gives us 4 square roots of 2 over 3 plus 3 over 3. And we can combine into 4 square roots of 2 plus 3 all over 3. And I guess that would probably be fine too. The final answer, the best form, it really depends on your application. All right, next example. Just one sec. All right, so we are going to break this up and simplify. So we got 3 times the third root, 2 over the third root of x to the 6th, minus 4 times third root of 5 over the third root of x to the 9th power. So we can simplify those denominators. So I'm just going to go ahead and move 3 up top. 3 times the third root of square root of 2 over third root of x to 6 is x squared. And then over here, we got 4 times the third root of 5 over x to the third. All right, now if we want to combine these, we're going to need a common denominator. So I'm going to multiply this fraction by x over x. And that gives us 3x times the third root of 2 over x to the third minus 4 times the third root of 5 over x to the third. And then we can combine them. So we get 3x times the third root of 2 minus 4 times the third root of 5 all over x to the third power. All right, your turn number 13. So let's break these up using the quotient property. And we will be able to simplify the numerator here and the denominator. So 24 breaks up into 8 times 3, and the 3 root of x and I is x to the third power. Then over here, 3 root of 7 cannot be simplified, so we'll simplify the denominator and get x to the fifth power. All right, now we're going to need to simplify here. I'm going to move these up into the numerators. So that gives us third root of 8 is 2 times 5 is 10. So we get 10 times the third root, 3 over x to the third, minus 4 times the third root of 7 over x to the fifth. Now we need a common denominator, so I'm going to multiply this one by x squared over x squared. And that gives us 10 x squared times the third root of 3 over x to the fifth minus 4 times the third root of 7 over x to the fifth. And we can combine them into one fraction, so that is 10 x squared third root of 3 minus 4 times the third root of 7 all over x to the fifth power. And that is it for today. I hope you all have a great day.